Thanks very much indeed for joining us today. Really appreciate it. Thank you.
It's a pleasure to come home.
So, how important is it that physicists communicate their research with diverse audiences?
Let's start with the idea of communication. I think it's very important for any scientist, including physicists, to be able to communicate what they do. And I would start small. I would start actually how you communicate with your family and with your peers. How you convince even at the American Physical Society your peers of what you do that is important and it's worthwhile to listen to. And if you succeed at that, the next step is really to go and start talking to a wider audience and take the opportunities that are given to us.
It's been put to me this week that the problem is that physicists are logical people. Physicists approach a problem and they look for a logical solution to that problem, and then they hit the real world. And in the real world doesn't necessarily work like that, which makes there a gap in that communication. So how does a physicist bridge that communication when what they're talking about is perfectly logical to them?
First of all, keep the logic intact, right? Because logic means credibility. And when I hear something doesn't make sense logic-wise, I always think of complex system, right? So I'm a network scientist, I deal with complex systems. And it's not that complex systems don't have a logic. It's just that when you push somewhere, the answer is not obvious because it spreads in a non-trivial way in a network. So when we think about complex systems and the emergence of the apparent lack of logic, it just means that we haven't understood enough about that particular system. So in that sense, I urge all physicists to keep the logic and to keep the rational approach to the even complex societal problems and seek how we could actually get the data and the approach that would give us a logical answer to the very complicated questions that we face.
Let's talk a little bit about your own work, your own research. What are you working on right now in your lab?
Well, there are several projects that we're excited about that. One of them has to do with understanding the cell as a network and to bring tools to medicine that would allow us to cure disease, diagnose disease, and so on. Why do we do that? Because life means interactions between the cellular components, just like consciousness means interactions between the neurons. And we need to map out these underlying networks to really understand first what does it mean to be alive, and second, how do we fix a system, a network when it's broken? Because most diseases are systemic diseases. There are so many different genes can lead to the same disease. How is that possible? Because there's a network and really the network is broken and there's so many different ways you can break a network. And so we need a network perspective to understand disease, and one research area in my lab really focuses on bringing the tools of network science, bringing the tools of statistical physics to biological problems and to medicine. But I'm just excited about physical networks, which is like the brain where the link has a physical existence, or material science. We encounter physical networks where we can now put together very complicated materials by 3D printing it. And one of the things I will be speaking about at this meeting is that how little we know about physical networks and what is the potential of understanding those problems.
Is there a role for network science in understanding climate change?
Oh yes, since the Gaia hypothesis, we understand the Earth works really as a very interconnected systems where multiple processes run in parallel, interact with each other. In the contemporary language, we would say the Earth and the ecosystem is a network. And it's a network at many different levels. It's a network of species that feed on each other. It's a network of climate processes that influence each other, and so on. So without a network perspective, we will not be able to understand the deep dependencies that are there in the climate. Hence, we will not know what button to push to achieve what we hope to achieve.
Thank you ever so much. We could talk for all day, well I could anyway, and thank you ever so much, really fascinating, thank you.
Thanks for the opportunity.